This is the video of the paper Logical Implications for Visual Question Answering Consistency. In visual question answering, or VQA, a deep learning model answers questions about images. The question and answer are in the form of text. In this paper, we deal with the problem of consistency. Imagine we ask this question about this image, and the model answers yes. Then, if we ask this second question, imagine the model answers yes again. This is an inconsistency. Clearly, the model should have answered no to the second question, like this. We can treat question-answer pairs as propositions. Then we can identify the relations that exist between pairs. Here is our method in 3 steps. First, we consider the logical relations between pairs. Then we penalize inconsistent cases at training time using a special loss function. Finally, we measure consistency using the relations. We start from the definition of inconsistency that says that 2 propositions are inconsistent if they cannot both be true. We use this notation to indicate that 2 pairs of question answers are related by an implication. Based on the definition of inconsistency, a pair will be inconsistent whenever the model predicts the first proposition as true and the second one as false. In this example, if the model answered yes to the first question, the pair will be inconsistent for any answer to the second question different from winter. Since there can be double implications or equivalences, we treat them as 2 independent implications. Since VQA datasets typically do not contain annotations about relations, we propose an auxiliary method to predict them. We leverage the task of natural language inference, or NLI, in which the goal is to predict if one sentence entails, contradicts, or is neutral to a second sentence. We pre-train BERT on the Stanford NLI dataset, and then fine-tune it on a portion of our VQA dataset which was manually updated. Finally, we predict the relations for the remaining part of the dataset using the fine-tuned model. This is the ROC curve for the entailment class. And these are some prediction examples. In this example, the model correctly predicts the relation. Sometimes, however, the model can make mistakes when the situations described in the propositions are unusual. Now, here is the core of our method. Given a pair of question answers that is related by an implication, we first define a function pi that gives the probability that the model predicts a proposition as true. Then we define a consistency loss that allows us to penalize inconsistent cases. As you can see in this plot, the function reaches maximum values when pi1 is high while pi2 is low, which corresponds to the cases in which the model is producing an inconsistent pair. We train the model using this total loss, which contains the typical loss function used in VQA and our consistency loss. Here are the results for the introspect VQA dataset. As you can see, for 2 different models and different baseline methods for consistency, our model improves the overall performance as well as the consistency. We also evaluated our method on a medical dataset, achieving similar results. Here are some examples from the introspect VQA dataset. For each picture, we show the ground truth questions and answers as well as the relation. Then we show the answers of each baseline. As you can see in the example on the top, all baselines correctly predict that the woman is sitting down. However, other baselines also predict that she is about to do a trick, which is an inconsistent answer. Our model corrects this. For more information, please visit our poster and website.